Hello everyone, I'm Nathaniel F. Moriba Jr., a student of Mawali University, studying Bachelor of Physiotherapy. So welcome back to my YouTube channel. In today's video, we are going to be talking about usefulness and limitations of arithmetic mean in the subject Biostatistics. So we are going to be discussing three major components when it comes to the usefulness of arithmetic means, and also when it comes to its limitations. We are going to be talking about three distinct components as well. So beginning with the first one, central tendency. In biostatistics, we know that arithmetic mean, they are used to analyze or to give a summation of a whole data which is represented by a single value. So in this central tendency is nothing else but just that sum or that number, that amount that has been calculated from the total number of data that was added, and then the sum of it can be written as a central tendency, which will be a single representation of that whole data. Comparative analysis, which is the second point in the usefulness of arithmetic means. Comparative analysis has to do with comparing data. Here, for instance, when it comes to the medical field, sometimes when it comes to treatments, or specifically in terms of effectiveness, this is where this data becomes very much useful, because here it compares the data on how effective it is from the other, like that. And then the second one is descriptive statistics. So now in this usefulness format, descriptive statistics give us a clue or a specific description about the data for which we are using when it comes to the arithmetic means in this context. So this descriptive data will give us a specific clue as to what are we describing or what the data is actually talking about. And in regards to that, arithmetic mean also comes with special consideration, which we can term as their limitations. So the first one here is sensitive to outliers. So for instance, these outliers are data which are separate, or they go their separate way from the usual data. So for example, if we have a data set that is going in this direction, in the outlier sensitive, in the arithmetic mean, you will find one person coming this side, which may affect the mean of this data. And secondly, coming to non-normal distribution. Non-normal distribution, we can easily link it with this example given up here, because what happens is that, let's take for example, we have this graph, these two graphs here. Yet consider this to be 1, 2, 3, 4, and 5. At this place, let's think that everyone here is receiving a salary of 40. And at this point, everyone here will be receiving maybe 30, 40, like that. And also on this side, someone will be receiving 40, but this is an equal distribution, so we consider it to be a normal. But when it comes to this side, which we are talking about now in this context, non-normal distribution, here you see that somewhere might be any out of 40, somewhere might be any 10, maybe 5, like that. But another person on the other hand of this graph might be any maybe up to 125, which will make the graph to divert to this side, indicating that these people are receiving less and this person on the side is receiving more, like we said here. And also when it happens, that it affects the mean as well. Now, coming to the last point here of biological variability. In the biological variability, we see that there will be no exact amount of variability when it comes to the arithmetic mean, when it comes to the biological side. Reason is because we cannot always get the exact number or the exact description when it comes to a group lining in terms of arithmetic means when it comes to biological variability. So most of the time you will find out that there will be some exaggerated or amount or some exaggerated data which might affect the data to be more like this. Thanks for watching this video. I hope you like and subscribe.